In this video, I'll be talking about the centipede. It's made up of two classes, the body and the head, which share a common base class, which is centipede, and this has common functions and variables that are shared by both to declutter the body and head. So things like the last tile, the position and the rotation, functions like getting the state and destroying the entire body. So the way the centipede works is there's a head at the front of every centipede that basically makes the decisions about where it's going to go on the mushroom field. And the update is optimized as much as possible. So it just increments this frame, every update. And using the finite state machine, it checks the index of the current offset and adjusts its position based on that. And then every tile, every 8 frames, we reevaluate and see where we need to go next based on our surroundings. So this isn't checked every single frame. This is we don't evaluate our surroundings every frame. This is just every 8 frames. And then the body doesn't even make any decisions. It purely just has a reference to the head in front of it or the body part in front of it, and uh, and just basically makes the move that it made last frame. So it's just playing copycat the whole time. Doesn't make any decisions the entire time. It just every 8 frames gets the next state from the body part or head in front of it and keeps on going. So the way the finite state machine works is we have all of these states which are created once and once alone. Here's an example of one. So we are creating a position offset based on how many frames we want to be traveling in. This is an example of 8. And so for this move left down, we split it up the movement over however this many frames, and then created an offset array, which is then referenced by the centipede. So this can be referenced by multiple centipedes at once, multiple centipedes at a different time. It always stays the same, and it's only calculated once, so this is very efficient. And then every 8 frames, we call this get next state by the head, and we do a surroundings check with the help of the mushroom field to determine what our next move should be, and then we move to a different state. So there's no, as you can see, no if statements other than the frame check here in the update. It's just very clean, and we just go completely by the state offsets. So the way the splitting works is if a head or body is hit by a bullet. So in the case of the head, we just destroy ourselves, which involves placing a mushroom down with the help of the mushroom field at the location we were just at, and then if we have a back reference, then that becomes a head. And the same for the body. We are gonna put a mushroom down, and then our back reference becomes a head, and we fix up the other references around here. So to become a head, we just create a new head where we were, delete ourselves, and fix all the references in between. For creating heads and bodies, we have a factory for each with an object pool. Here's my factories. So this is the centipede body factory. We just send in a request for what frame is it on, how long is this centipede, a front reference if there is one, and we initialize, we pull a centipede body or head from the pool, and we initialize it with those values. And then once it's run its course, we recycle it back here to be reused. Centipede body pool. So this just has a stack of body parts here. And that's so we don't have to do new and delete every single time we create a new centipede head, which is pretty costly. Let me make sure there's nothing I'm missing. Yeah, I think that's about it for the centipede.